Now we see the probability distribution of a random variable. In the last lecture we see the definition of the random variable. Here the random variable is a real number associated with each outcome of a sample space, okay, of a random experiment. Any random experiment we take, a coin is tossed, 2 coins are tossed, 3 coins are tossed, or a die is rolled, 2 dice are rolled, any random experiment. Here we take one random experiment, 3 coins are tossed, okay. Here see carefully, when 3 coins are tossed, then the sample space, the total outcomes are here. All 3 coins shows heads, or 2 coins shows heads and third coin is a tail. 3 coins are tossed. Here in the first outcome all are the head. In the second outcome 2 heads and 1 tail. But 2 head and 1 tail, there are the 3 possibilities. Tail in the third coin, or second coin, or the first coin. Therefore here we take the third coin. Now tail in the second coin, it is H T H or T H H, okay. That are the 3 possibilities of 2 head and 1 tail. Again it is a 3 head, then 2 heads. Now 1 head, when 1 head appear, we toss the 3 coins, 1 head appear, that means the other 2 are the tails. But again head on the first coin, on the second coin, or the third coin, okay. If head on the first coin, then second and third are the tail. If head on the third coin, then first and second are the tail. If head on the second coin, then first and third are the tails, okay. Here now these are the 4 possibilities. Total possibilities are 8. 3 coins are tossed. Then here this 4 possibility, it is out of 8, there are the 4 possibility, and remaining 4 possibility we can write directly. It is tail, tail, tail. Only replace head by tail and tail by head. Tail, tail, head, and it is tail, head, tail, and it is a head, tail, tail. Okay, see carefully this. 3 heads, then 2 heads, 3 possibilities. Then 1 head, there are again 3 possibilities. 1 head, 2 tail, 1 head, 2 tail, 1 head, 2 tail. Head on the first coin, head on the second coin, head on the third coin, and there is a no head. That is 1 head, 2 head. It is 3 heads, 2 heads, 1 head, and it is a 0 head. Okay, here these are the 8 possibilities. 3 coins are tossed. Then number of yes is equal to 8. Now here experiment is a coin tosser. When a coin tosser, then we get head or tail. That means we count head or tail. Here we take a random variable, number of heads or number of tail, anywhere. Here we take the number of heads. Okay, let the x number of heads Okay, now we count the number of heads. Random variable we take x, then the value of the random variable from the sample space. Okay, each outcome, random variable is a real number associated with each outcome of a sample space. There are the 8 outcomes, and here random variability is the number of head. That means in the first outcome there are the h, that means the 3 heads. Second outcome h, that is the 2 heads. Here it is a 2 heads, here it is a 2 heads. Here it is 1 head, here it is 1 head, and here it is a 0 head. Okay, that means the random variable x takes values 3, 2, 1 or 0. That means we write in the ascending order. The random variable x takes values 0, 1, 2 or 3. Okay, therefore random variable x takes values 0, 1, 2 or 3. Okay, see carefully this. Okay, random variable x is a number of head. We count the number of head in each outcome. Okay, here it is x in a first outcome, h. Here x is a number of head. There are a number of head are the 3 in the first outcome. The second outcome H H T. Here second outcome, X is a number of heads, then we count the number of heads. H H, there are the 2 H, therefore it is a 2. When X third outcome, it is H T H, again there are the 2 heads. X is a number of head, and the fourth outcome it is a T H H. X is a number of head, then count the number of heads in the fourth outcome, again it is a 2. Then X is a, it is fourth outcome, we can write T T T, it is a 0. Then X, it is a T T H, it is one head. X is a number of head, then it is T H T, again it is 1. And X, it is the last outcome, H T T, again it is 1. Okay, here X is a number of head, and we count the number of head in each outcome. Number of head in each outcome, it is a number of head, and there is a no head, therefore number of heads are, it is a 0. And that means the random variable X takes value 0, 1, 2 and 3. Okay, 0, 1, 2 and 3. Okay, total outcomes are the 8. Now here we find the probability of each random variable. Random variable, there are the 4 random variables. It is a 0, 1, 2 or 3. Okay, we want to find the probability distribution of a discrete random variable. Okay, here discrete random variable, it is a random variable takes a finite number, it is a 0, 1, 2 or 3. We want to find the probability of each random variable. Okay, now see carefully. First find the numbers. Here number of X is equal to 0. X is equal to 0 means number of heads are the 0. Okay, here we find the numbers. Okay, when 0 heads appear only one time. Okay, therefore here the number of X is equal to 0, it is 1, and therefore the probability of X is equal to 0, it is 1 by 8. Okay, 0 heads appears out of 8 outcomes. Okay, here 0 head, 3 coins are tossed, then 0 head shows 1 outcome out of 8 outcome. That means the probability 1 by 8. Then number of X is equal to 0, sorry, X is equal to, now we take 1. X is equal to 1, X is equal to 1 means 1 head. Now in the out of 8 outcomes, there is a 1 head, here it is a 1 head, 1 head and 1 head. Therefore there are the 3 possibilities of the 1 head. Okay, then X is a number of head, therefore 1 head shows 3 times. Okay, 1 head, here it is 1 head, here it is 1 head. Therefore probability of X is equal to 1, it is a 3 by 8. That means 1 head shows 3 outcomes out of 8 outcomes. Okay, then number of X is equal to 2. 2 heads shows again 3 outcomes, and therefore the probability when X is equal to 2, it is again 3 by 8. Then last, the number of X is equal to 3. Here X is a number of heads, 3 heads shows only one time. Okay, therefore it is 1. Then probability of X is equal to 3, it is 1 by 8. Okay, see carefully this. Here it is a random variable 0, 1, 2, 3, random variable 0, 1, 2 and 3, and there are the probabilities of the random variable. It is when X is equal to 0, random variable takes value 0, then their probability is 1 by 8, because X is the number of heads, and here number of heads are the 0. When 3 coins are tossed, there is only one possibility when 0 heads, that is when all tails, then that is the 0 heads. Here the possibility of 0 heads, it is a 1 out of 8. Then probability of X is equal to 1, X is a number of head. Here random variable X, it is a number of head, X is a number of heads. Then X is equal to 1, that means the one head shows 3 possibilities. Here TTH, THT and HTT out of 8. That means it is a probability 3 by 8. Again 2 heads, X is equal to 2. 2 heads again 3 times, therefore it is probability 3 by 8. And X is equal to 3, that means 3 heads. Again there is only one possibility of all heads. When 3 coins are tossed, it is one possibility, it is H. therefore it is a probability 1 by 8. It is a probabilities of a random variable. Okay, here probability distribution of a random variable. Now this probability distribution and the random variable, probability of random variable x is equal to 0, it is probability it is 1 by 8. The probability of a random variable x is equal to 1, it is a probability 3 by 8. Probability of x is equal to 2, its probability it is a 3 by 8, and probability of x is equal to 3, its probability it is a 1 by 8. Now these probabilities we write in a tabular form. Okay, see carefully. Here the probability distribution of random variable x is, see carefully, x is a random variable and random variable it is a number of heads. Now here x is a random variable and x takes values 0, 1, 2 and it is a 3, and then probability of x when x is equal to 0, the probability it is 1 by 8. When x is equal to 1, probability it is a 3 by 8. When x is equal to 2, probability it is a 3 by 8. And when x is equal to 3, probability it is a 1 by 8. And it is a probability distribution table. Okay. Here it is a probability distribution of a random variable x. And here x is a number of heads when 3 coins are the tossed. It is a probability distribution of number of heads when 3 coins are the tossed. See carefully this. It is a probability distribution. Random variable takes values 0, 1, 2 and 3. There are the 4 values, that is x, it is a random variable, it is x1, x2, x3 and it is a x4, and the probability it is a p1, p2, p3 and p4. Here random variable takes 4 values, it is x1, x2, x3 and x4. The probability, corresponding probability of x1 it is a p1, probability of x2 it is a p2, probability of x3 it is a p3 and probability of x4 it is a p4. Okay, now we write the definition of the random variable. It is a probability distribution. Okay, see carefully here. Okay, remember this, it is a probability distribution of a 3 coins are the tossed and it is a probability distribution of a number of heads. Here we write the definition of the probability distribution. Let x be discrete random variable takes values x1, x2, x3 up to xn with their probabilities p1, p2, p3 up to pn respectively. Then the probability distribution of random variable x is given by, here it is a x is a random variable and x takes values x1, x2, x3 up to xn and their probabilities, it is p1, p2, p3 up to pn. Okay, here this x we can also write it is a x is equal to xi and here probability x is equal to xi, where I is equal to 1 to n. Okay, and here it is a probability distribution. Okay, here we take the values of the random variable x1, x2, x3, x4, x5 up to xn. Okay, in a particular random experiment, here random experiment, it is a 3 coins are tossed. There are the 4 values of the random variable. It is x1, x2, x3 and x4 and their probabilities. Okay, here we take any one more example. Here it is a probability distribution. We take a die is rolled. Okay, here then the total outcomes 1, 2, 3, 4, 5 and 6. Okay, here a die is rolled. It is all possible outcomes. That means the number appear on the uppermost face. Now therefore the number of yes, it is 6. Now let we take a random variable x number on uppermost face. Number on a uppermost face when a die is rolled, a single die is rolled. Okay, when we roll a die is rolled, then number on a uppermost face, it is either 1 or 2 or 3 or 4 or 5 or 6. Okay, that means here the random variable takes values 0, 1, 2, 3, 4, 5 and 6. That means the number appear on the uppermost face. It is either 1, either 2, either 3, either 4 or it is 6. Okay, here therefore the random variable x takes values it is 1, 2, 3, 4, 5 and 6. Okay, now here we find the probability of each random variable. Okay, we want to find the probability of each random variable. See carefully this. Probability of each random variable. Random variables are 1, 2, 3, 4, 5 and 6. Therefore number of x is equal to 1. See carefully, x is equal to 1. That means number on the uppermost face is 1. And then how many time it is appear? 1 shows only one time. Okay, here when a die is rolled, 1 appear, the possibility of 1, it is only one time. Therefore it is 1. And then probability of x is equal to 1. It is 1 by 6. Because total outcomes are the 6 and possibility of 1, it is a one time. And it is probability 1 by 6. Then number of x is equal to 2. The possibility of 2, again it is one time. 2 appears only 1. Therefore its probability, it is a probability of x is equal to 2. Again it is 1 by 6. Then number of x is equal to 3. Again it is 1. Therefore its probability, it is 1 by 6. Then number of x is equal to 4. Again it is 1. Probability of x is equal to 4. It is 1 by 6. Number of x is equal to 5. It is again 1. Therefore probability of x is equal to 5. It is 1 by 6. And last, the probability of x is equal to 6. 6 shows on uppermost face only one time out of 6. It is 1 by 6. Okay, here these are the random variable 1, 2, 3, 4, 5, 6. Here the probability of random variable 1, it is 1 by 6. Probability of random variable 2, it is 1 by 6. Probability of random variable 3, it is 1 by 6. Therefore the probability distribution of random variable x is, here it is x. X takes 6 values, x1, x2, x3, x4, x5 and x6. That is 1, 2, 3, 4, 5 and it is 6. And then probability of x, probability of 1, it is 1 by 6, 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 and it is also 1 by 6. Here it is a probability distribution of a random variable x. Okay, see carefully this. Here x takes values 1, 2, 3, 4, 5 and 6. There are the 6 values x1, x2, x3, x4, x5 and x6. It is p1, p2, p3, p4, p5 and p6. It is a probability distribution table of a number on an uppermost face when a die is a roll. A single die is a roll. Okay, a single die is a roll. Then there are the 6 possibilities. Okay, see carefully this. Now it is a probability distribution of a discrete random variable. Now we see the probability mass function. Probability mass function. In the short, it is called PMF of discrete random variable. Okay. Now again here, let x be a discrete random variable, takes values x1, x2, x3, x4, x5 up to xn with their probabilities p1, p2, p3, p4 up to pn. Then the function is called probability mass function. Probability mass function if there are the two conditions. All probabilities are satisfy the condition of the probability. That means all probabilities are, it is in between 0 and 1. That means 0 less than or equal to probability less than or equal to 1. Okay, it is a pi. Here I is equal to 1, 2, 3 up to n. Okay, p1, p2, p3, p4, p5, p6 up to pn. All probabilities in between 0 and 1. And the second condition, it is sum of all probabilities where I is equal to 1 to n is equal to 1. Okay, sum of the all probabilities is equal to 1, and all probabilities satisfy the condition of the probability. Probability, it is a in between 0 and 1, and sum of the all probabilities, here it is our last example. Sum of the all probabilities, when we adding the all probabilities, it will be 6 by 6. That means 6 by 6 it is 1. That means this function is a probability mass function. Okay, the probability mass function, here the condition of the probability is satisfied. Probability is non-negative and less than or equal to 0. Non-negativity is a 0 less than or equal to probability less than or equal to 1, and sum of the all probabilities is equal to 1. It is called the probability mass function. Okay, see carefully this. It is a probability mass function. Sum of the all probabilities is equal to 1, and it is a satisfy the condition of the probability. Okay, probability distribution, and it is a probability mass function. Okay, see carefully this.